Hello, everybody. This is Coach Meinbauer here for AP PreCalculus. We are on section 4.9, vector valued functions, which is really just combining vectors and parametrics together. As you can read there for a definition, a vector value function is a vector, usually represented by vector r, which are just variable components, really, because we're using parametric equations. Okay, so example one, given the vector of r, which is going to be the horizontal component is 3 minus 1/2 t. The vertical component is 2 root t. First thing, let's find that domain. So real quick, if we read up here, the domain is the intersection of the domain of x of t and y of t. So the domain of 3 minus 1/2 t, well, that domain, that's a line. All lines have the same domain of negative infinity to infinity. And then the domain of the vertical component, which is 2 root t, that is a square root. So we have to be between 0 and infinity, and we can equal 0. So we're going to combine those together. So those intersect. Where do those overlap at? If I were to make those onto number lines, where do they overlap on the number lines? They would overlap here at 0 to infinity, because this is where domain x of t and y of t overlap. Okay, so we're going to make a table and sketch r of t. So this is just going to be a vector of a parametric. So make a little table here. So do I have restrictions? I do, actually. It doesn't tell me where to stop, but I know that t has to start at 0 for my domain. And we'll do this at x and y. So we're going to start at 0. And when I plug in a 0 into that, I'm going to get 3 minus 0. So this is just 3. When I plug it into y, I'm going to get a 0. So we are here at 3, comma 0. I'm going to use t equals, we can do 1 on the next one. T equals 1. We're going to get 3 minus 1/2, which is 2.5. And then we're going to get 2. So 2.5, and then up 2. Next number to plug in is probably best is 4, because 4 we can plug into that square root. That's going to give us a value of 1 for x, and then a value of square root of 4 is 2 times 2 is 4. So 1, 4. Okay, and then I'll probably have room for one more here. Plug in a 9. When I plug in a 9, I'm going to get 3 minus 9/2, which is negative 1.5. And then when I plug a 9 into the vertical component, that's going to give me 6. So we're kind of just estimating that 1/2 right there, but we're going to start here. And this is going to start to kind of curve off over here. And there is that vector r of t. I'll label it as well. R of t. So we have to find the magnitude of r of t at 4. So r of 4 is equivalent to, I have it right here, 1 comma 4. So the magnitude of r at 4 is what we learned last time. It's just the square root of each component is root 17. All right, that represents as this vector valued function is moving from 0 upward. When we're at 4, the speed is about root 17, or it is root 17. Okay, so that's how fast it's going. Determine the particle motion at t equals 9. So what's great is I have this up here. So I have r of 9, which is negative 1.5, comma 6. So the horizontal component is negative, so we are moving left. So this is the particle motion. We're left because x of 9 is negative. And then the 6 represents the up or down. Since we're positive, we're going to represent up because y of 9 is positive. All right, let's move on forward. All right, we have a vector now. If hopefully you remember this from previous lessons and what shape this is. What shape is this? It's a good answer. Let's see if you're right. Determine the domain of R of t. Well, luckily here we have trig stuff. So the domain of both of these are going to be from negative infinity to infinity. So they're going to overlap at negative infinity to infinity. So the time does not matter for us, the t value. Okay. Because the domain of cosine goes on forever left and right. And the domain of sine, same thing, goes on forever. So let's go ahead and make a table here in Sketch. Since I'm dealing with sine and cosine, I'm just going to deal with just my quadrantals. So start with 0. When I plug in a 0 here for x, I'm going to get cosine of 0, which is 1 times 4. So we get 4. Plug in a 0 into sine, I'm going to get 0, so I'm going to end up with 3. Next quadrantal is pi over 2. Plug that into x, and I'm going to end up with a 0. Plug that into sine. That's because sine is 1, so I'm going to get 5. Plug this into pi. Cosine is going to be negative 1, so at negative 4. And sine produces a 0, so back at 3. And then 3 pi over 2. When I do that, I'm going to get a 0 for cosine. And then I'm going to get negative 1 for sine. So 3 minus 2 is 1. So I'm going to get 0, 1. Draw this. I didn't draw this in the right order. Ooh, I've seen better. I can do better. I'll draw this in the right order then. So I started here. Coming around, you can see the direction here for this. Okay, that is an ellipse. Okay, this is the form of an ellipse. We've seen that before in previous notes. What's the magnitude at 5 pi over 4? So real quickly, we didn't find this on our table, so we got to find this out ourselves. What's our 5 pi over 4? What is that vector? So we plug in a 5 pi over 4 up into cosine. We're going to get... what are we? Third quadrant, so it's going to be negative here. We're going to end up with negative 2 root 2. Because we're going to get 4 times 2 root 2. When I plug that into the sine, I'm going to end up with 3 plus root 2 minus root 2 because it's third quadrant. 3 minus root 2. Yeah, that's what I got. So, and I find the magnitude of this. This is not a pretty answer. Negative 2 root 2 squared plus 3 minus root 2 squared. Honestly, that's a great answer right there. I will just kind of simplify it for you, though. If you do want it to simplify it on your own, you're going to get 8 for the first term, and then it's going to simplify a little bit. I got 19 minus 6 root 2 inside of the square root. You can type that in the calculator and get a number. I didn't. Sorry. Don't know what that represents. Couldn't tell you. If I'm guessing, I don't know, root 2 is like a little over 1.5 times 6. Just call it 10-ish. Makes it easier. 19 minus 10 is like 9-ish, which is about 3. So it's about 3-ish. All right, last part. Oh, part A, I should say part D. D as in done. Almost done. Can't speak. Determine the particle motion at 11 pi over 6. Okay, so plug this into R. So 4 times cosine of 11 pi over 6. That's a lot. Root 3 over 2 family. I'm going to end up with 2 root 3. 11 pi over 6 into sine. That's going to give me a negative 1/2. So it's just a 2. Yeah, perfect. Make sure those are chevrons there, not parentheses. I almost do parentheses. Okay, so what's the particle motion? Well, we are going up because x of t is positive. And we are going, oh, hold the phone. Hold the phone. Who's on the phone? It's not a thing anymore. I'm going right because x of t is positive. We're still going up. And we're going up. I just went in the wrong order. I was so focused on being letter D done. I didn't really see this one through. All right, here we go. That's our video. Please like and subscribe.